Hello, hi everyone. I believe I am live now. So, a very good evening to all. Those who are joining me live, please give me a quick confirmation in the chat window that whether I am clearly audible, properly visible, or not. And we will be waiting for a few minutes so that everybody will join our discussion. And after that, we will start our today's objective. Okay. So today's session will be an enhancement of, I would say, deep learning playlist only. So as you can see, it's a episode number 17th, which I am considering, right, where we will be discussing about that how, with the help of these CNNs model that we have covered up so far, we will be able to build GAN architecture. So before this era of generative AI, chat GPT, prompting, agentic AI world, this GAN architecture was the one which actually helps us to generate the images, videos, and so on. So we will talk about it, and then we will see that how there is a shift from that GAN architecture towards this generative AI world, right? So just wait for a few more minutes. I have seen many people have already joined us, so I just welcome you all. We will try to wait for a few more minutes, and then maybe we'll start our discussion. Let me, in the meantime, just check the settings as well. And if you have any quick questions, any doubts, you can just mention in the chat window in the meantime. I'll just take all those questions and then we will start our discussion very soon. So if there are any questions, please let me know. And also, I have seen no confirmations yet. Can you guys give me the confirmation also? Am I clearly audible or not? Please give me the confirmation. Am I clearly audible or not? We'll start our discussion. Okay, perfect. So let's get started. Let me share my screen first and just give me a quick confirmation is my screen is also visible to everyone or not. Okay. So I hope my screen is also visible to everyone. Perfect. I think we can start our discussion now. Um, and in the meantime, in between, if you feel there are any questions, any doubts, you can just let me know in the chat window. Okay. Also, just again, a further reminder that we will be starting very soon our new course on Data Careers Launchpad. This month only, 16th May, the very first live discussion will be there in the morning at sharp 9 a.m. IST. So please make sure that if you are interested, maybe if you're not aware about this, I'm just letting you know once again. So over here, you can see if you will go inside this explore courses, you will find the new one. This is Data Career Launchpad. If you'll go inside this enroll now button, by default, it will give you the package number one, which includes only DA specific course. So we will be having the live sessions also. You will also get the recorded discussions as well. So it's kind of a hybrid, you can say. But yeah, initial sessions for the very first week will be live, where I will just try to talk about the complete end-to-end illustration of this course, why it is important, and every week we will meet once at least and discuss the entire flow of the class and whatever with the recorded sessions I'm sharing. If you have any doubts, you can connect with me. I'm the only mentor who is leading all these modules, so you will get my personalized guidance in this specific course, right? Another thing, you can use a coupon code data20 to get 20% discount further on top of it. If there is anyone who was not enrolled previously in my DSA course or ML course, you can check for the package number 2 and package number 3, where with just minute changes in the prices, you will get an access of other courses of mine as well to get a better preparation of your entire data ecosystem part. So this is another announcement. Please, if you are interested, if you're facing any issue, any doubts you have, you can always reach out to me via my email. Either you can reach out to me via Tech for All with Priya email ID, or there is another email my ID of mine, admin@the rate Tech for All with Priya. So both of them, I'm the only one who is managing, so I'll respond back to you as soon as possible. Okay. Now let's go back to our main discussion of today's session. How many of you have already watched all the episodes of Deep Learning? How many of you have already watched all my episodes of Deep Learning? That's the question I have for you all. Yep. So if you know that in my channel, uh, this is the playlist, right? This is the playlist which I have, which includes very starting discussions where we will be having the introductory part of deep learning. And then step by step, I have tried to convey the concepts of multi-layer neural networks, activation functions, CNNs, CNN-based architectures. There was in the previous part of our episode, we have discussed about one interesting project as well regarding this real helmet detection part. So, how many of you have gone through all these episodes already? If not, if you have left any of these episodes, today I'm just requesting you all that if you really want to gain a true insights of each and everything, how the flow is going on in deep learning, try to watch these episodes one by one, right? In a sequence. Today we will be focusing on this GANs architecture, which is the episode number 17th. So even if, let's say, there are many people who might not be available because today is the working day and they might be in the office, or they might have some personal work as well, so they can always watch this under episode number 17. So you can also write in the comment section once the session will be over for other people reference in the comment section. Okay, this is the episode number 17 and it is recorded. So everything, every detail you will get even after the discussion. So let's say in future you want to take a reference again. So it's not that it's a one-time session which is happening. But the idea is कि because it's a live discussion, the benefit is you can always ask me the questions in the chat window. On my other screen, I have a chat window opened up. So I'll just take your questions side by side and try to answer them, right? Perfect. Let's get started now. A very interesting, I would say, a very close to my heart discussion of GANs. So when I learned about these GANs for the very first time, I was amazed to see the results about this. So today I'm just trying to showcase you my experience on that. So you are scrolling today Instagram, right? I think few days back I was just watching a reel of Dhruv Rathi, and he was just saying that there was a image uh, of some lady, uh, and her profile was very active, not from India, outside India, and many people usually comment that, share those videos, not videos, photos with each and every one, and that author was making a lot of money from that. But recently they get to know that that specific lady doesn't even exist at all. So it was the AI generated image which that author was posting. He was a guy and he was making a lot of money from them. So the idea is that when we're scrolling on Instagram, we see a person who looks completely real, perfect lighting, perfect face, but when we see this kind of news that person is not real, it doesn't exist at all, no camera, no photo shoot, no human, it's just AI. So we get amazed to see that kind of results, right? Have you ever checked that? Have you ever seen these kind of things happening at your end कि आपने किसी प्रोफाइल को सर्च किया हो, एक्सप्लोर किया हो, और उसके बाद आपको पता चला हो कि ये प्रोफाइल जेन्युइन है ही नहीं, राइट? सब कुछ रियल दिख रहा है बट इट्स जस्ट दैट इट्स AI based. So these GANs are the ones which helped us to generate these kind of images, right? So today, what I'm trying to show you is that how machines learns to create something called as reality, which we called as GANs as well. GANs की full form क्या है? किसी को पता है? What is the full form of GANs? Anyone has any idea about it? GANs full form है Generative एडवर्सरियल नेटवर्क्स. अच्छा, इसका काफी इंटरेस्टिंग रिसर्च पेपर भी आपको मिल जाएगा इफ यू विल चेक. गैंस रिसर्च पेपर बहुत इजीली मिल जाएगा आपको. आप यहाँ पे जाना, जस्ट क्लिक ऑन दिस व्यू पीडीएफ, और आप ऑटोमेटिकली इस पीडीएफ को डाउनलोड भी कर सकते हो, और इसके साथ में ही आप इस पीडीएफ को पढ़ भी सकते हो वंस योर सेशन विल बी क्लियर फॉर टुडे. तो आपको समझ में आना शुरू होगा. ऑब्वियसली इसमें बहुत ज़्यादा मैथ्स इन्वॉल्व होगा, बट जो मोटा मोटा हम यहाँ पे डिस्कस करने वाले हैं, वंस यू गेट दैट आइडिया इन अ क्लियर डेप्थ, यू विल बी एबल टू गेट द अंडरस्टैंडिंग ऑफ गैंस फॉर श्योर. इसको हम बाद में पढ़ेंगे, व्हाट इज दिस एब्स्ट्रैक्ट ऑल अबाउट, वंस वी विल रैप अप अवर डिस्कशन फॉर टुडे, so that we'll get a very good idea about GANs, and we get the confidence after reading the abstract that okay, now we understand these abstracts. Okay, let's come back. So we understood that the full form is generative adversarial networks. Fine. Now, as the name itself says, generative. So over here, our main purpose is to generate something, right? That's why it's called as generative adversarial networks. Now, what actually we are trying to generate over here? That's the next question. By the end of this session, you will understand that how GANs actually work. That's the first objective of today's discussion. Secondly, you understand that why they started Gen AI revolution that we have in 2026. And next thing, you understand that how this actually connects to your career in AI. Means why it is important even today. It's not that they are obsolete architectures, you should not have any idea about it. No, ideally, you should be aware about all these things if you know that you already have learned deep learning, right? It's very important topic, and it's connected in terms of your interviews, in terms of your generative AI world, whatever you work over there as well. Okay, let's start with a very simple question. Let's say कि you create a machine learning model which creates something new. Will that be possible? Till so far in our journey, I think I also have my ML playlist available on my channel. In fact, many of you guys have already be a part of my applied ML specialization course on my website, Tech for All with Priya. And I believe at least my audience knows about this. Ki when we talk about machine, and specifically the machine learning architectures, we know that when we talk about ML, or let's say we talk about machine, and when we think that can machine create something new, we always have that question mark. Why? Because we have seen that machine can do a classification task, and this part is already solved. We have seen that machine can do some predictions. Maybe it is a regression specific scenario, maybe a house price prediction. And this part was also already solved. We have seen so many numerous, I would say, algorithms in the machine learning domain. And we are very sure that it's not a difficult task today to do a classification task, even by ML models or by DL models. In fact, in my DL playlist, you already have done that job as well, right? अगर आप लोगों ने सारे एपिसोड्स देखे हैं, इम्प्लीमेंट किए, तो आपको पता है कि इमेज क्लासिफिकेशन कोई बड़ी बात नहीं है. अगर आपने एमएल के कोर्स को अच्छे से पढ़ा है, तो यू ऑल नो दैट इट्स नॉट अ बिग डील टू create a classifier, to create a classification based model if we are working on a numeric data. प्रिडिक्शन करना भी कोई बड़ी बात नहीं है. तो बड़ी बात क्या है? जनरेशन. दैट इज वेयर इनिशियली रिसर्चर्स स्पेंट अ लॉट ऑफ टाइम. जनरेशन पे काफी बड़ा क्वेश्चन मार्क था. एंड दिस इज वेयर आई मीन ऑलमोस्ट लॉट ऑफ ईयर्स हैव बीन स्पेंट कि क्या मशीन कुछ जनरेट भी कर सकती है. प्रिडिक्ट कर रही है बेस्ड ऑन हिस्टोरिकल डेटा, दैट इज फाइन. क्लासिफाई कर रही है कि ये कैट है, डॉग है, दैट इज ऑल्सो फाइन. पर क्या अगर मैं उसे एक लेट्स से प्रॉम्प्ट देती हूँ, तो विल इट बी एबल टू जनरेट अ इमेज फॉर मी? ट्रेडिशनल मॉडल्स, ट्रेडिशनल मेथड्स, दे जस्ट लर्न पैटर्न्स. तो आप जितने भी अभी तक के जितने भी मशीन लर्निंग मॉडल्स के बारे में जानते हो, या जितने भी हमने पढ़े हैं, यू ऑल नो दैट all these traditional models in the ML space, in the DL space, they just learn patterns, but they don't create new data at all. क्या आपने कभी देखा है किसी भी मशीन लर्निंग मॉडल को काम किया हो और वो आपको डेटा जनरेट करके दे रहा हो? नहीं देखा होगा। जितने भी मॉडल्स हमारे पास इस स्पेस में है, डीएल के अंदर या एमएल के अंदर, जितना भी एटलीस्ट मैंने अपने यूट्यूब पे डिस्कस किया है, एवरीथिंग रोटेट्स अराउंड क्लासिफिकेशन, प्रिडिक्शन, but never ever till so far in my career in this specific channel I have talked about that how these models will be able to create a data. Yeah, I have a generative AI playlist as well. That's a different discussion altogether. But I'm talking in reference with ML and DL. कभी नहीं देखा होगा, कभी होता ही नहीं, था ही नहीं. And that is where researchers also have spent a lot of time. And then came a breakthrough idea. The idea was about GANs that we're covering up today, right? So they said that, in DL, usually we create single model, which we call as a CNN model, right? They told us ki why to create a single model, why not create multiple models together. Multiple mean the sense two models specifically I am saying. So now I am jumping towards a very interesting part, which is about a GANs architecture discussion. So they said that we will create something called as two models now. Till so far in our history, we have created only single CNN model. But today, for the very first time, they gave a thought that why not to create two models and make them compete. दो मॉडल्स क्रिएट करते हैं और उन दोनों में कंपटीशन लगाते हैं. उन दो मॉडल्स के नाम पता है क्या थे? There was first model which was named as generator. नाम से पता चल रहा होगा. The main purpose of this generator part is to create fake data. इस जनरेटर का मेन पर्पस क्या था? फेक डेटा को क्रिएट करना. And then we had something called as discriminator. So these are the two models we have, generator and discriminator. The main purpose of the second model was to detect whether data is fake or real. It's kind of, you can say, discriminator is a kind of a classifier which is doing a classification task, where it was saying that if it is a fake image, I will mark it as, let's say, 0. And if it is a real image, I will mark it as, let's say, 1. So this was the main idea. Idea क्या लेके आए वो? कि we will create in this architecture two models together. फर्स्ट मॉडल वॉज जनरेटर, जिसका मेन काम सिर्फ इतना होगा कि वो एक फेक डेटा को जनरेट करके देगा. वी एज अ यूजर विल प्रोवाइड सम रैंडम डेटा, उसको वो फेक डेटा में कन्वर्ट करेगा कुछ इस तरीके से कि बाय द एंड ऑफ द डे डिस्क्रिमिनेटर मॉडल जो है, डी मॉडल जो है, वो डिटेक्ट करे और वो बोले कि ये तो रियल है. दैट्स द होल गेम, दैट्स द होल आइडिया. सो आई हैव वन क्वेश्चन. Is sound generation too is as difficult as image generation? I won't say it's difficult right now. There are so many interesting enhancements which have already happened. So I won't definitely say it's difficult. Right? My audio is good. Can I get a quick confirmation? I just now have checked my settings. It was not connected with my mic at all. Now I think I have connected with my mic. Is it better now? Is my audio is good previously also? You guys didn't told me. Otherwise, I checked my settings previously itself. But I think now it is better, right, everyone? There is no echo, quality improved. I hope so, because now mic is connected. Perfect. Shall we move further? All good till so far? Any quick questions anyone is having? Better, no? Okay. Shall we move further now? All good?
Perfect. So you can consider that there is a guy, okay, there is a guy who used to generate fake currencies, which is a very illegal thing. So you can consider a generator as a guy who used to create fake notes, ठीक है, जो नकली नोट बनाता है बेस्ड ऑन आवर रियल नोट्स, वो रेप्लिकेट करने की कोशिश कर रहा है. एंड यू कैन कंसिडर द डिस्क्रिमिनेटर in a real time illustration as a police who is responsible to catch whether this note is a real one or this note is a fake one. So by the end of the day, what is happening is कि generator actually tries to improve. Generator tries to improve. Basically, it tries to create as real notes as possible so that it will be automatically used in the markets. And police also becomes better by looking onto the fake notes. And you can consider that this process continues. तो एक तरीके से हम ये बोल सकते हैं कि एक तरीके से कंपटीशन हो रहा है दोनों के बीच में. जो फेक पर्सन है जो कि फेक नोट्स क्रिएट कर रहा है और जो पुलिस है जो उसे पकड़ना चाह रही है. अब बार बार नोट को जनरेट करते हुए जनरेटर भी इंप्रूव हो रहा है, वो बंदा भी इंप्रूव हो रहा है जो कि फेक नोट क्रिएट कर रहा है, और पुलिस को भी नॉलेज मिल रहा है बिकॉज ऑफ टू मेनी इन्वेस्टिगेशंस हैपनिंग अराउंड इट. सो बाय द एंड ऑफ द डे दोनों ही आपस में एक तरीके से इंप्रूव होने की कोशिश कर रहे हैं विद टाइम. द सेम थिंग इज हैपनिंग इन द जनरेटर डिस्क्रिमिनेटर केस इन अ रियल वर्ल्ड एज वेल. कुछ कुछ इंट्यूशन समझ में आ रहा है. तो होगा क्या? आई एम राइटिंग नाउ इन टर्म्स ऑफ स्टेप्स. व्हाट इज हैपनिंग ओवर हियर? व्हाट आर द कोर स्टेप्स? ठीक है. So let's try to discuss what are the core steps that we have. Perfect. This is the thing that we have learned. Now I'll talk about the core steps now. Just listen it very carefully with respect to whatever discussion we have done. तो होगा क्या? In this kind of architecture, the step number 1 is that generator creates fake images from noise. ठीक है. सबसे पहला काम क्या होगा? हम जनरेटर मॉडल को एक नॉइजी पॉइंट्स देंगे, एक नॉइजी डेटा पॉइंट्स देंगे, और उन डेटा पॉइंट से जनरेटर कोशिश करेगा कि वो एक फेक इमेज को क्रिएट कर पाए. ठीक है. स्टेप 2 में डिस्क्रिमिनेटर आएगा एंड इट सीज टू थिंग्स. एक वो चेक करेगा रियल इमेज क्या है, और एक वो चेक करेगा कि फेक इमेज क्या है. फेक इमेज इज ऑब्वियसली गिवन बाय द जनरेटर मॉडल, and real image you can assume that model already have. ठीक है. Step number 2. Step number 3. Step number 3 क्या होगा? Step number 3 में first step, second step, and let's talk about third step now. In the third step, discriminator gives the feedback, right? Ideally, अगर ये क्लासिफायर अच्छा है, अगर डिस्क्रिमिनेटर बहुत बढ़िया काम कर रहा है, तो मुझे एक बात बताओ, डिस्क्रिमिनेटर क्या फीडबैक देगा? डिस्क्रिमिनेटर क्या फीडबैक देगा? What will be the feedback ideally by the discriminator? Tell me in the step number 3. What is the feedback by the discriminator in the step number 3? Who will tell me? As an ideal model, as an ideal classifier, what is the feedback by the discriminator? क्या मैं बोल सकती हूँ अगर डिस्क्रिमिनेटर काफी स्ट्रांगली वर्क कर रहा है तो वो एक सही रास्ता देगा? वो बोलेगा कि real is 1, fake is 0. Let's assume. Yes, everyone. Then only you can say that this specific model, classifier model, is working really well. अब उसके बेसिस पे अगर उसने सही पकड़ा, पुलिस ने सही पकड़ा, डिस्क्रिमिनेटर ने सही पकड़ा, तो जनरेटर क्या करेगा? जनरेटर ट्राइज टू इम्प्रूव एंड दिस लूप कॉन्टिन्यूस. जनरेटर कोशिश करेगा कि अरे डिस्क्रिमिनेटर तो पकड़ रहा है मेरी चीज को जो मैं फेक इमेज क्रिएट कर रहा हूं, तो वो क्या करेगा? वो कहेगा कि ठीक है, मैं और इंप्रूव करने की कोशिश करता हूं. आई विल ट्राई टू इंप्रूव मोर एंड आई विल ट्राई टू जनरेट बेटर फेक इमेज. And that's how this loop will continue. Until what point of time? This will happen. Until what point of time? Until this loop will stop at a point, you can say, where discriminator gets confused and consider, we can say, the fake image as real image. अब वहां पे एक तरीके से डिस्क्रिमिनेटर फेल हो जाएगा, जनरेटर की जीत हो जाएगी. इसका मतलब अब जो जनरेटेड इमेज है वो इतनी सॉलिड है कि मॉडल कंफ्यूज हो गया, मॉडल समझ ही नहीं पा रहा. इसका मतलब देयर आर वेरी हाई चांसेस कि अ रियल ह्यूमन बीइंग विल आल्सो गेट्स कंफ्यूज्ड and people will consider that as a real image only. I hope you're getting my point. And today, I mean, this research paper, if you will see, it was back in 2014. We are in 2026. You can imagine ki from the last 12 years, how the things have changed drastically. And this AI world, this generation world has evolved so much. Today, creating the videos, audio, images is no more a big deal, right? We can just write a prompt. How many of you knows about a platform called as DALI? How many of you knows about a platform called as Midjourney? DALI, Midjourney. कितने लोगों ने इस प्लेटफॉर्म के बारे में देखा है, सुना है? DALI यूज भी किया होगा. So if you can see, it's a series of text to image model जिसमें you just have to write a prompt कि आपको image कैसी चाहिए, and with the help of this open AI it will be able to generate a image for you. You can imagine the vastness of this specific model, this generative models. Similarly, if I'll search Midjourney for you, those who are not aware about it, generative artificial intelligence service that creates high quality artistic images from NLP. So again, you have to provide the prompt and it will create an artificial image for you, and that too with the super quality. So all these tools have been evolved from the idea of this GANs only. समझ में आया? क्या हमें आर्किटेक्चर क्लियर हो रहा है? So basically, अगर ऐसी बात है, तो can I say that over here, the core purpose of this entire model, the entire game, is actually to minimize the generator loss so that it will be able to get a better results, better realistic images, and maximize the discriminator loss so that discriminator will fail to recognize which is real and which is fake. Isn't it? Isn't it? That's the end goal. Can we say, everyone? How many of you understood the point clearly with respect to the GANs architecture? समझ में आया? So let's assume over here you can consider that we will be having something called as a real image. We will be having something called as a real image. Now, a real image might have some specific distribution. You can consider that it's a normal distribution only. Now, what will happen over here? You will be having one architecture of discriminator. You will be having one model of discriminator, and then you will be having another model of generator, as we have discussed. Now, what will happen over here is that you are passing over here some random noise. You are passing over here some random noise. कुछ भी randomly हम pass कर रहे हैं. This will be passed towards this generator. What will happen is generator will try to read this random noise, tries to create some fake data out of it, or you can say fake image out of it, whatever be the cases, if you're passing an image. Perfect. So a fake image will be created. Here you will be having a, let's say, real image. Let's assume, and let's take it as the same architecture. So over here, with the same dimensions, we will be having something called as a fake image, something like that. Now you can consider that this real image will also be passed to this architecture of discriminator, right? And you can assume that this fake image is also be passed towards this discriminator. Getting my point? Now, this discriminator will try to understand that whether these two images, one is what we have is the real image, another one is what we have is the fake image, whether these two images are same or not. Discriminator will try to give me the answer as either 0 or 1. So kind of you can consider that over here, we will be having internally somewhere around sigmoid function working in. I hope if you have already been seen my videos of previous episodes, you know that sigmoid function is actually helpful for our binary classification task. And this is actually a binary classification task only. So the sigmoid function will either give the result as 0 or 1. So obviously in the initial run, it will say that, hey, it's a fake image. Answer is 0 in the initial predictions, right? So in the initial predictions, my model will be quite strong. It will give me the result as 0 because it's a completely random image. We will be having too many noisy data points. Now what will happen is, as per its prediction, there will be a loss which will be passed, which we are calling as a discriminator loss. So over here, there will be a discriminator loss, and that is very less. And over here, there will be a loss which is what I'm calling as a generator loss, which will be too high because initially the picture is very bad. So over here, you can imagine that there is another loss working around, which we call as generator loss. Now, both of these laws are competing. Ideally, in order to have a good model, these loss value should be minimum. दोनों की लॉस वैल्यू मिनिमम होनी चाहिए. अगर मुझे बेस्ट से बेस्ट मॉडल चाहिए तो डिस्क्रिमिनेटर लॉस भी कम होना चाहिए, जनरेटर लॉस भी कम होना चाहिए. बट दोनों कम कैसे हो सकते हैं? अगर दोनों कम होंगे तो आई वोंट बी एबल टू विन. I won't be able to create a realistic fake image. So by the end of the day, somehow discriminator loss will start increasing, generative loss start decreasing. It means that there comes a point after some prediction, after some iterations, where the prediction will start become 1, which says that this fake image is actually a real image. And that is the point where your model will stop training. What kind of real image take discriminator? You can consider any image. Now you can think about maybe your image. You can pass your image by the end of the session. You might have your images in your gallery, right? You can pass your own image, and over here you can pass some random image from website. By the end of your training, this fake image should look like you. This image will definitely have some dimensions. Let's assume your image is having a dimensions like 224 cross 224 cross 3. Let's assume it's a uh, RGB image. Obviously, we are in an era where we all have RGB images only. So just one thing you have to make sure that when the fake image will also be created, this is of same dimensions. This is something we have to make sure in our code. And I will showcase you how you can make sure that. We will do the implementation as well. Is the idea of this GAN architecture is pretty much clear to everyone. This is the realistic architecture which I have created over here. Can you please explain about sigmoid? Dekho, sigmoid is a kind of a activation function which we have used in machine learning also when we were talking about logistic regression. Karthik, you can check my ML playlist where I have talked about logistic regression part. And in the deep learning, there is a video of activation functions. There you will find again the sigmoid activation function topic. But just to give you an insight, this function is having some equation, which is you can definitely check at your end as well. Sigmoid function and its corresponding graph. So this is how this equation looks like: 1 upon 1 plus e ki power minus x. So the curve you can see, kind of a curvy nature, you can see. So the sigmoid activation function is very widely used in the industries whenever we want to do a binary classification task. So internally, it actually gives us the probability of these two classes. So it actually internally gives me the probability of a fake image as real and the probability of fake image as fake. Somehow you can understand like that. Let's assume that if the probability is more than 0.5, so the output will be 1. So there is a threshold criteria. By default, it is 0.5. If it is more than 0.5, the output will be 1. If it is less than 0.5, the probability part, which it actually helps us to evaluate, the output will be 0. That's how it will be able to give me the output as either 0 or 1. And that's the intuitive idea about it. So always remember, whenever you are doing binary classification task, meaning at the end of the day, you just have two classes, you will always and always in the entire data science domain, I am saying in general, will be using something called as sigmoid activation function. On the other hand, if let's say at any point of time, you will be having a situation where you are doing a multi-class classification task. It can happen, right? You can have multiple classes. So always remember, in that scenario, we have something called as softmax activation function. And I think I must have talked about this also in my discussions, in my previous episodes. So the softmax is actually derived from sigmoid only, if you will check the equation of it. Okay? So always remember, for the classification part, either sigmoid will be used or softmax will be used. It actually, what these activation functions will do, it actually brings up the known linearity in our data, and based on their equations, it actually provides the probability of each class. And whichever is having a higher probability, definitely that will be the class it finally belongs to. Whether it's about real, fake, whether it's about cat, dog, whether it's about having multiple classes, so on. I hope it is fine. I hope it is fine. Now, what are the real-time applications of these architecture? Let's talk about that topic. Do we have any real-time application of this GANs architecture? Let's talk about that. What do you think? Any applications which you can say? Today, though, we are using so many of this generative images. So what do you think? What are the core applications we have about this architecture? Any guesses, anyone? सबसे पहला task, data augmentation. Do you know the meaning of data augmentation? If you will formally search this definition of data augmentation, it's a very interesting thing which happens in deep learning domain. You can see it helps us to artificially increase training data set size and diversity by creating modified versions of existing data. So, in data augmentation, you try to get the modified versions of existing data. So, in this, you will try to do a flipping of an image, you will try to do a rotation of an image, you will try to find some artificial image, and so on. Okay? This process is what we call as data augmentation. Always remember, when we talk about deep learning domain, in general, I am saying, when we talk about any deep learning domain, any architecture, when we train our model in deep learning using CNNs, they are data hungry. What does that mean? It means that you will be able to get better results only when you will provide enough data. But there are few domains in our real life scenarios where getting the data is kind of a difficult task for us. Any example of it? Yes, we have multiple examples. Maybe you can talk about healthcare domain. Till today, there are so many diseases where we don't have enough data. If let's say I want to integrate AI into it, I need huge chunk of data. Let's talk about a disease which was not there, maybe we do have because of our lifestyle, and I want to integrate that AI into it so that my machine will be able to tell whether this specific patient will have that specific problem or not. So I need enough patient data. How will I collect it? I have a limited data available. And that is where in healthcare domain, to get the artificial images of the patient's data who is suffering from some, you can say, um, bigger issues or diseases, there we can integrate AI models by training them with huge amount of data, by collecting artificial data from these types of models. I hope you're getting my point. Is it fine? Is it clear to everyone? So wherever you can see, I have just given you one simple example of healthcare because personally I have worked in that specific domain in my masters at IITH. But you can imagine there are multiple problems like that. There are multiple domains like that where we don't have enough data till so far, and that is where uh, we can get a huge collection from this specific technique of generative AI or GAN specific architectures for us. Now, today you see diffusion models. Today you observe that there are so many generative AI based models like GPTs that we will be having. After this discussion, try to check their internals about it. You will observe the basis was this GANs, because that was the first model which actually gives the idea of generating something, an image. So that is the important crux of it, right? Now, just spend some time and read this research paper, just the abstract of it. And now let me know whether you will be able to understand this abstract or not. You can see we propose a new framework. This is by, you can see these are the authors of this research paper, for estimating generative models via an adversarial process. Acha, what do we mean by adversarial? Why it is called as adversarial? So if you will see the adversarial meaning, what is the meaning of it? Process involving two or more parties in conflict. समझ में आ रहा है इसका नाम ऐसा क्यों दिया गया? So the full form of generative means we are trying to generate something new. Adversarial meaning Literal meaning is that we are trying to have two models which are conflicting with each other, which are competing with each other. That's why adversarial name is there. Network, it's a obviously CNN based network only which we are working on. I hope it makes sense. So let's move ahead now. Just read this read this lines. I'm just giving you a few minutes. Read this and let me know in the chat window whether this abstract is clear now or not. Whether we will be able to understand this abstract or not. We propose a new framework for estimating generative models via an adversarial process in which we simultaneously train two models. Generative model that captures the data distribution. Obviously, every data, when you try to provide real data, have its own distribution. Random noise have its own distribution. So it tries to capture the data distribution, real-time data, realistic image data. Discriminative model estimates the probability that a sample came from training data rather than G. The training procedure for G is to maximize the probability of D making a mistake. That's the end goal of generative model. This framework corresponds to a mini-max two-player game in a space of arbitrary functions of G and D. A unique solution exists with G recovering the training data distribution, D equals to half everywhere. In this case, where G and D are defined to multilayer perceptrons, entire system can be trained with backpropagation. We'll talk about it within few minutes when we will we will be doing the implementation. But over here you can understand कि दो neural network layers हमारे पास में है, तो obviously weights training होगी, back propagation होगा, they will be learning step by step in every iteration. And over here you can see, I mean, you can read about this entire research paper, but this is the very first architecture which includes min max cost function. We are minimizing generative part and maximizing the discriminator part. Over here, you can see the entire research paper further, but you can see that that's how the output looks like. So you can see this yellow area is kind of a generative image by learning from these patterns. Perfect. Is this entire thing is clear to everyone? अभी तक जितना हमने डिस्कस किया, क्या हमें क्लियर हो रहा है? All good till so far? I'll share with you one interesting website. Maybe after the session will get over, you can definitely go ahead and play with this website. Over here, you have different sort of distributions available. Okay, you can also create your own distribution, and you can check that how this uh, generative models actually work. Over here, you can see, for example, I'll take this specific data distribution and I'll start running this epochs. So you can see the generator part is getting some noise. It is passing inside this fake sample. Over here, we will be having real sample also. Discriminator is taking both of these samples, real and fake. And after that, we will be getting, you can see the discriminator loss and generative loss based on the predictions of the sample. And over here, you can see this layered distribution. So in this layered distribution, this green dots indicates the real samples, and this pink dots which you can see indicates a fake sample. So you will observe that in every iteration, it is trying to make sure that I will be able to get a fit in a way that I will be able to get that kind of distribution which real samples belongs to. तो यहाँ पे अगर आप देखोगे जैसे जैसे आपके नंबर ऑफ इपॉक्स इंक्रीज हो रहे हैं, ये एट द एंड ऑफ द डे ये मेक श्योर कर रहा है कि जो आपके आई वुड से रियल सैंपल्स है वैसा ही डिस्ट्रीब्यूशन जनरेटिव सैंपल्स भी क्रिएट कर दें. And when that part will be done, that is where it will say that okay, training is done. Obviously a lot more epochs will be required, so you can just do it at your end, but by the end of the day you will be able to see that this pink dots will be correctly overlapped over this green dots. So over here you can see what is GAN. Read about this after this session. This is your task for today. How does GAN work? Now you will be able to get a proper idea, because now you already have understood in my live discussions the intuition behind it. Please read this as well. And what is happening in the visualization, they're talking about that as well, to have a better understanding of it. बट मोटा मोटा जो हमने डिस्कस किया वही सब है. तो अगर आप इस आर्टिकल को पूरा रीड करोगे तो आपको और बेटर आइडिया मिलेगा कि यहाँ पे हो क्या रहा है. So this is the task for today. Maybe anyone again in the comment section, those who are with me in the live discussion, please mark your attendance by commenting it out. The task which I have shared, so that if anybody new will come on this specific video, they will get to know in a correct way ki what actually we have covered up. Really like those kind of comments where learners come, they understand, they implement, and then they summarize what is the actual learning they have gained in the video. So they summarize in the comment section that this is something which Priya has discussed in this specific discussion. These are the pointers, cut to cut, short notes. This is a reference for you and for others as well. And then this is the final task which you have to do. Just read about this article to have a better understanding of it. So I'm looking forward to it. Who will be the one in today's session? Okay, perfect. Now the last part is the implementation. Now, the problem is that when we talk about GAN specific architectures or any in general deep learning based models, doing a live implementation is difficult. I did an implementation few hours back before this live discussion. You can see the timing 7:37, right? The idea was ki it took a lot of time to train the model. In fact, over here I have just decreased my epochs to 5. Initially I have taken 20. It was taking a lot of time. I reduced to 10. Again, it was taking a lot of time, so I reduced to 5. But at your end, I'll share this entire data with you all. You can always refer my GitHub repository. I hope everybody knows about my GitHub repository. All the YouTube related videos content you will find over here. So Python programming playlist that we have, there might be a master class which I have taken maybe in the past. Their notes is there. Netflix analytics dashboard notes are there. How Amazon know what you will buy notes are there. So every specific discussion which I usually does, whether it's a live or a recorded one or a playlist one, everything you will find in my GitHub repository. So whether we have deep learning playlist repository or not, I have to check because I also don't remember these things. Yeah, I have that. So maybe what I'll do, I will try to update inside this episode number 17 specific content as well. Okay. So you will find all the notes over there. Just after the session, I'll share with you all. Okay. So what I have done over here, so I won't try to rerun this file again because it takes a lot of time as I have mentioned, but I'll try to give you an intuition behind it, how these things are working fine. Always remember, when we create any deep learning architecture, let's say you have some layers, right? This is a flattened layer, maybe the input layer you have. So obviously we have image data. You know that image data will be converted into pixels. I hope everybody knows that, right? So let's say when we pass our raw image, this raw image is nothing, but it's a internally for the model pixel values in a matrix. After this, you will observe that we have something called as the concept of kernels, right, everyone? So there could be multiple kernels which we might be using in our work. There could be multiple kernels, and on top of it there will be a implementation of CNN based models which will help me to identify the patterns in a given image with the help of these kernels. So let's assume that I got by the end of the day something called as a feature map. All these things I'm assuming you all know from my previous episodes. So if anyone is not aware, please refer that. Feature map you will be able to get. Now, once you will be able to get the feature map, ideally what you will do is you will try to do a flattening of it. And you can consider this as an input layer. You will do the flattening of this layer. After this input layer, you will be having obviously few hidden layers. something like that. And then there will be some output layer by the end of the day, which will be giving the output, whether it's a classification task or a regression task based on that. That's how our neural network architecture looks like, everyone. Do you guys agree with me? ऐसा ही होता है ना? होता है कि नहीं होता? Now the important thing which I'm trying to convey over here कि जितना ज़्यादा आपकी deep network layers होती हैं, जितनी ज़्यादा hidden layers होती हैं, तो एक्चुअली में होता क्या है कि initial hidden layers in a neural network tries to find the common, I would say, patterns in the given image. जैसे आप बोलोगे कि इनिशियल हिडन लेयर्स एजेस निकाल रही है, एजेस फाइंड कर रही हैं, फिर आप अगली हिडन लेयर पे गए, उसने पैटर्न्स डिटेक्ट किए, नेक्स्ट हिडन लेयर में इमेज के पैटर्न्स आए, उससे नेक्स्ट हिडन लेयर में लेट से उसने एक ऑब्जेक्ट को शेप किया और उसके बाद एक फाइनल शेप बना. दैट्स हाउ स्टेप बाय स्टेप मीनिंगफुल images patterns will be observed, right? That's how the overall things will happen in general. अब obviously जब मैं initially कम epochs लगा रही हूँ, I have used only 5 epochs, so you can assume that initially it is just trying to fetch the initial edges and the patterns of a given image. I have used over here MNIST data. For those people who are not aware about it, MNIST is a very common data used in deep learning, which is having specifically the digit based data. So MNIST data contains the images. It's a grayscale based images of 0 to 9. So you can imagine this kind of a data is there. 5, 0, 1, 4, 9. So it's an image based data which contains 28 cross 28 size images. Grayscale images means only single channel will be there and digits are there from 0 to 9. That's the whole point, okay, in this specific image. Now let's come back to the specific plan. So over here, I have just imported everything. I'm using TensorFlow framework to do the implementation. I have loaded the MNS data. I have normalized it. Always remember, GAN specific architecture works well when you have a normalized values of a given pixel values in the range from -1 to +1. So I have done that. I have just used the train part minus 127.5 because maximum pixel value is 255. So divide by 2 is 127.5. So I just try to normalize it in the range from -1 to +1. I have just taken 20,000 initial samples. The only reason was to do the faster training. Initially, I have taken 60,000 in total, but the training was very slow. So that's the only thing I have done over here. I have taken the buffer size as 2000 and batch size as 32. So we have already loaded our data. This is the important thing. So we have built a generator. It's a sequential model where we will be having a dense layer of size 7 into 7 into 256. So you can imagine how many number of what we can say neurons will be there. And I have taken initially 100 samples over here. The point over here is you can understand कि 100 random noise based images हम यहाँ पे pass कर रहे हैं. 100 fake images हम यहाँ पे pass कर रहे हैं. Batch normalization we are doing to normalize our layers, and then we're applying a leaky ReLU activation function to add the known linearity in our data. Finally, we are reshaping our image to 7 into 7 into 256. That's the reason why we have taken this specific number of neurons. After this, you will observe that I am using something called as conv 2D transpose part. Dekho, by the end of the day, what I want is, I want my fake image to look like real image. So obviously, I want that the dimensions will remain the same, which is of 28 cross 28 cross 1. So this convolution 2D transpose, what it is doing is, it is trying to enhance your image size. So what will happen is 7 cross 7 will become 14 cross 14. 14 cross 14 will become 28 cross 28. So that's what you are doing over here. You are using 128 number of kernels with 5 cross 5 as the, I would say, kernel size. Stride is 1 comma 1. So over here, the size will remain 7 cross 7. But when you will increase the stride value to 2, multiply the image size, it will become 14. And then finally, it will become 28. So by the end of this specific architecture, you will be able to have a fake image of size 28 comma 28 comma 1, right? I hope it is clear to everyone. Just like the way in the convolution part, when you apply a convolution layer, feature map will get reduced, output image will have a lower size. What's the exact feature map size? We have a formula, which is n minus f plus 2p divided by s plus 1. Again, if you don't know, please refer my previous episodes. Similarly, in convolution 2D transpose also, when we apply this maths, we have a formula to get the final image size. But in general, I am saying whatever the stride value you have, multiply with the original size of the image. So stride is 2 comma 2, you're applying a convolution to the transpose, 7 to the 14. Again 2 comma 2, 14 to the 28. That's how you will be able to get at the final end of the day model, which contains a final image of size 28 cross 28. So basically, in this specific part of building a generator part, it will be helping me to generate the fake images at the end of the day of size 28 cross 28. Now we come towards discriminator. What it is doing? It is again building a sequential layer where in every layer now we are trying to classify whether it's a real or a fake image. So I will be having a convolution 2D layer, 64 kernels, 5 cross 5 is the size, stride 2 comma 2. But over here, my input shape is 28 comma 28 comma 1 because my real image is also having a shape of 28 comma 28 comma 1 and my fake image is also having the same size. Again, I'm applying a leaky relu. I'm applying a dropout. For those people who don't know, dropout is used to overcome the overfitting. So that's why I'm applying that. So it by default, shut off that 30% of the neurons which are working internally. Then again, we're applying a 2D convolution layer. Then again, leaky relu, again dropout. Same thing. Finally, we are doing a flattening. And after that, we're applying a single dense layer, which is giving me the output. Finally, we will be able to have a discriminator over here. We will be using a cross entropy function, which is a binary cross entropy, because over here we are doing a binary classification task. We are making from logic set true because over here I'm not looking for the exact probability. I'm looking for the exact numbers, which will be quite fine for me to get the calculations done. Again, we have a generator loss, which will be simple cross entropy, and then we have a discriminator loss. In the D-specific architecture, where main purpose is to do a classification task, we will be having a real image loss and we will be having a fake image loss. The final result will be the addition of what is the real loss we're getting and what is the fake loss we're getting, right? Because for both the contexts, we will be having a loss value available. So over here, we are saying what is the correct output you're getting and what is the real output you have. So over here, we are saying ones, over here, we are saying 0, because we know that real part indicates the result as 1 and fake part indicates the result as 0. That's the whole point. Then we have an optimizer. We're using an Adam optimizer over here. We have just called an object of build generator and discriminator. Finally, the training is happening. This is very important step. This is whole part of the code relies on this. So what is happening in this part of the training is what you are doing. You are passing a noise which contains normal distribution by batch size 32, which you have defined for 100 images. So for 100 specific images, you are passing a normal distribution, individual of batch size 32. It will keep on coming. Now what is happening is in a generator part, you will be passing the noise. You will be making training as true because you want that the weights to be updated so that you will be able to build a generated images at the end of the day. So this generator function will try to build a generated images. Then we have a discriminator. Whatever images we have, we are again passing the training as true. So this images is a real image and then we will be having a generated image. So we are passing two things. One is the real image, so we'll get the real output. One is the generated image, we'll get the fake output. Then we'll try to evaluate the loss for both of them. We will get the generative loss, we will get the discriminative loss. Now, as per the loss, we have to update the gradients. Now, over here, you should know about how the gradient descent optimizer will work into picture. When we update the weights, we use the formula like W new is equals to W old minus learning rate into derivative of loss with respect to the weight. This derivative of loss with respect to the weight is kind of a, we can say, gradient. So over here, we're trying to evaluate this gradient value. And then we're trying to apply these gradients so that the weights will be keeping on updating. By the end of the day, you will be able to get the generative loss and discriminative loss. Now we have a generated images simple function. What is the noise we will be having? What is the predictions we're getting? We're just defining it with the subplot as 4 cross 4. Basically, we want 4 rows and 4 columns. And that's how our image looks like. So you can see when I tried to use this epochs, that was the result in the initial run which I got. Very initial stage where you can see generative loss is there, which is quite low. Discriminative loss is quite high. We keep on moving up. You can see in the epoch 1, it is just getting the sense of the edges. In epoch 2, it is trying to find some real thing areas. In epoch 3, some new unique areas it is trying to find out, observing maybe the patterns of it. In epoch 4, you will observe that some meaningful values are highlighted, remaining are basically the black zones, black areas. Epoch 5, again, it is just getting the real ones, real, I would say, रीजन्स जहां पे लाइट हमें को हमारे को शोकेस हो रही है, बाकी सब ब्लैक हो चुका है, बट अभी भी कुछ मीनिंगफुल रिजल्ट नहीं है. आई बिलीव अगर हम इसको और इंक्रीज करेंगे इपोक्स को, आफ्टर दैट वी विल बी एबल टू गेट एन आइडिया कि एक्चुअली व्हाट द स्पेसिफिक numbers indicates. So what is the task for you all is try to increase this number of epochs. How many of you knows about a technique of callback? If you don't know, please search about it. Callbacks. Basically, you can try to use this callback technique where you can write a maximum number of epoch, and by default it will automatically check the loss, and it will just define by itself ki whether I should keep on continuing the training of the epochs or I should stop over there. So ideally it should stop at a point where the model of D, discriminator, will be confused and try to state that okay, this real image, this fake image is actually a real image. So just explore about it, callbacks in context of epochs, and this actually helps us to avoid the overfitting in the models as well. So that's the whole context of this Gen AI, this GAN specific architecture, where we will be having two models, two losses. So when I'm just doing a training part, you can understand the whole architecture over here. We are passing a noise. We are passing inside this generator the noisy values. In the discriminator, we will passing the real image, generated image. We'll get the real output, fake output. Based on that, we'll get the loss values, and then we're trying to evaluate the gradient and we're trying to apply them so that in the optimizers it will keep on updating the weights until it reaches to a point where we will be having an optimized fake images. That's the whole crux of it. Why we subtract and divide by 127.5 on training data? It's a technique of normalization, Biswajit. So if you remember, in our machine learning, we have a technique called as min-max scalar. Do you know that? So what we do in min-max scalar, we try to take the entire value. So min-max scalar in a scalar. So you will see, it will take the original data value, subtract it with minimum value, divided by maximum minus minimum. Over here, we will be able to get the scaled value with the help of the specific formula. In general, when we do normalization in the range of -1 to +1 for any image, maybe over here we're not getting something, but you will observe that we will be having a pixel values, right? Image will always be in the range from 0 to 255. So in general, what we try to do is, when you try to take a division by this 255, the middle value of 255 in terms of pixel value, it is approximately 127.5, if I'm not wrong. Right, everyone? 255 divided by 2. exactly 127.5 is coming up. So general formula will be, take that input value, whatever value you have, minus 127.5 divided by 127.5. So what will happen is when you subtract with the middle pixel value and divide it by that, you'll be able to get a normalized value within the range from -1 to +1. And that's the core reason behind it. I hope it makes sense to you. So that's the overall idea about it. Any questions anyone is having? Any doubts? Now, this code part, only those people will be able to gain the understanding. Those who already have built previously the CNN based architectures. If there is anyone who directly came today and learn about this GANs model, you will face a difficulty in terms of implementation. So the main prerequisite is just refer the previous episodes first, try to build a basic level CNN based model, and then come towards the specific architecture. I hope it is clear to everyone. All good? So I will share this code file, this entire notes, and this entire link as well. So maybe I will attach this in the collab itself. Reference link. Just have a look onto it. One more thing, again, if you are interested, please go ahead, check this course out. We will be meeting on 16th of May in the morning 9 a.m. One important thing, I have added the Gen AI portion also in this course, because I have observed, I have talked with a lot of my friends who are working in this domain as well. Now, in any data ecosystem, you will observe DA, data science, data engineering. Gen AI is something which is a common thing asked by many people in the interviews itself. And even when you work in the industries, you should know that how you will integrate this Gen AI in your work. So we will try to talk about, with respect to DA world, how you can use this Gen AI space in your work, right? So I'll try to share my experiences also. I will try to share my friends' experiences also. I will try to talk about that how we can, when we're doing a SQL, EDA, or faster analysis, we can do with the Gen AI part. So there is a revamp of the curriculum happened. Uh, I think I have done few days back only. So you can have a look onto it. Uh, this is one of the very interesting project which I'm doing in this specific year, and I am personally very excited to launch this specific part with you all. So I'm looking forward towards the serious learners in this specific batch, and let's try to build a great community of data ecosystem where all the people who are genuinely interested in data part, we will all be together. uh, Very soon I will open the Telegram group for the same. In the very first class, I will share that group link as well with the enrolled learners. So if you are genuinely interested, please go ahead and enroll it. I will see you all in the course. With that, I think we can wrap up for today. I hope that you find today's session very insightful, very meaningful. If you want me to come live more frequently, please do mention in the comment section. If you will share the video, if you will support me in terms of commenting it out and helping me to reach to the wider audience, definitely I will try my level best to spend more time with you guys as well, right? With that, I think we can wrap up for today. Thank you so much everyone for joining in. Looking forward towards your comments. With that, I'll see you all in the upcoming discussion. Bye bye. See ya.